Hello and welcome back to another tricky A-level maths exam question. This is day 3 or question 3. It has been a while since I last did one of these, approximately about 3 months, so it has been quite a big break, but we are back, right? And we're going to go through plenty of tricky A-level maths exam questions. So this is day 3. We'll quickly run through this question. This is a question here, as we can see then on series and summation. Now, this isn't the most trickiest question in the world. It, certainly has challenging parts to it. But I certainly think that part B here and part C should be applicable to most students. Part A might be a little bit more challenging if you haven't seen a question such as this one before, but let's just run through it anyway. So, like we just said then, let's just begin here with part A. I'll just start over here, just so I've got a little bit more room then. I always kind of run out of room, so hopefully that won't be the case for this question. So what we want to do here is show that this summation is equal to lambda, where lambda is just an integer to be found, right? Now, there was a very similar question quite a few years back now. I think it was 2019 off the top of my head. And at the time, that question had caused quite a few problems. I think nowadays, if that question was to come up, it wouldn't be quite as challenging because, students have that exposure to this type of question. But again, if you haven't seen this question, I do think it's a little bit more challenging. So what I've got here is this summation. So sigma from n equals 1 to 104 of log of n plus 4 over n plus 3. So n plus 4 all over n plus 3 base 3 is equal to lambda. So what I would recommend here is just doing the first few terms and then maybe the last 2 terms, and you should be able to see what's going to happen with this series, right? So the first term here is when n equals 1. So when n equals 1, what I get here is 1 plus 4, so that's 5, all over 1 plus 3. So I get 5 over 4 here for log base 3. So log 5 over 4 base 3 is my first term. So log 5 over 4, like we just said then, base 3, like so. My second term then, well, my numerator will increase by 1. The same will apply to my denominator, right? So I get log of 6 over 5, again, base 3, 6 over 5, base 3. The third term here is going to be log 7 over 6, and again, base 3. And this would just keep going on and on and on up to the very last term here. So my last term then is when n equals 104, as we can see from the sigma notation here, right? And in that case, then what I'd get here is log of, so I get 104 plus 4, so that's 108 all over 107. So the denominator is always 1 less, right? So 108 all over 107, like so. And again, base 3 here. Okay, if you do want to, you might find it useful to do the penultimate term, so the second to last term here. I don't think it's particularly necessary, but you might just find it helpful to see what's going to cancel in just a moment. Okay, now what I've got here is a summation of logarithms, right, which all have the same base. So you should be aware then that one of the properties here for logarithms is that we can combine this as a single logarithm, right? So what I get here is log of, so we'll have base 3 here for our logarithm. And what we get here then is 5 over 4 times by 6 over 5 times 7 over 6 times so on and so on, all the way up to the very last term here of 108 over 107, right? So 6 over 5 times 7 over 6 times so on and so on. And this goes up to the very last term here of 108 all over 107. Perfect. And hopefully what you recognize here then is that basically a lot of things are going to cancel down here. This 5 would cancel with this 5. This 6 here would cancel with this 6. This 7 here would cancel with the next denominator. Obviously we can't see that because I've not done that term, but you get the idea, right? And in this case here, this 107 would cancel with the numerator of the previous term here. Like that, right? Again, I haven't kind of denoted that term, but you get the idea. And what we get left with then is log base 3 of 108 over 4. So 108 over 4. So 108 over 4, that just simplifies to give us 27. So what we've got here is log 27 base 3. And that is just simply 3, right? So log 27 base 3 is just simply 3. Okay. And there we have it then. So that gives the solution to part A there. So in that case then, just to finish with here, let's just state that lambda here, which is an integer to be found. In this case then, lambda is 3. Perfect. Good stuff. So that's the solution to part A. Hopefully, I wouldn't say not too challenging, but like I said, if you haven't seen a question like that before, then you might find that a little bit more challenging. Okay. Now, for the next part of this question, then, what we're told here is a geometric series is given by the following. So 3 plus 6x plus 12x squared plus so on and so on. What we're also told here is that the series is convergent. Now, all we want to do here then is just write down the range of possible values of x. So for part B then, what we need to do here is just make use of the fact that the series is convergent, right? Because we know then for a convergent geometric series here, the condition that we require is that the common ratio here, r, the modulus of r, is straight less than 1. So if convergent, then in that case here, the modulus of r is straight less than 1. In other words, all we mean here is that r is between -1 and 1, right? So put it underneath then, r is between -1 and 1, okay? So what is the common ratio here? So just take the second term and divide it by the first term, or alternatively, what you could do here is take the third term and divide it by the second term. It really doesn't matter which way you do this. But obviously the easiest way is to take the second term and divide it by the first term. So r here is equal to 6x over 3, which just simplifies to give us 2x, right? So in that case then, what we're saying here is that the modulus then of r, which is 2x, so the modulus of 2x is straight less than 1. And what we can do here is just simplify this, right? Let's just divide 3 by 2 then. And what we get here is that the modulus of x is straight less than 1 over 2. So in other words then, x must be between -0.5 and 0.5. Okay, so just do that up here then. What we're saying here is that x is between -0.5 and 0.5 there. Okay, just put a bubble around that as well. Just so you can see here, either of these is fine, whichever way you prefer to denote it. That's what we'll get there for part B. And now for the very last part of this question then, what we're given here is the following summation. So the summation here from r equals 1 to infinity of 3 times 2x to the power then of r minus 1 is equal to 4. And all we want to do here then is just find the value of x. Now what you need to recognize here is that this summation will give you these terms here. Okay. You can kind of evaluate that by just taking r equals 1, r equals 2, r equals 3, and you'll get, for r equals 1, you'll get 3, for r equals 2, you'll get 6x, and then for r equals 3, you'll get 12x squared, so on and so on. But basically, the parts of the question here are structured in such a way, you know, to help you answer the next part of the question, right? So for part C then, let's just do this underneath here. Like we said, we're given this summation here. Now, what do we know then for the summation? Well, I know the first term is 3. So A is 3. We don't know what x is here, right? Because x is part of the common ratio. So I don't know what x is. And in that case, then I don't know what r is as a consequence of that. But what I do know here is the sum to infinity, right? What we're told here is the sum to infinity. So we're going from r equals 1 to infinity. In other words, it is the sum to infinity. We're not the sum to infinity here is 4. Okay. What we will do, because we're going to need it for the calculation anyways, we'll just take r as 2x. Okay. Like I said, we don't know what r is. It's just 2x, and we don't know what x is. So as a consequence, we don't know what r is, if you get what I mean. But for now, we'll just take it as 2x because we will need it in our calculations here for the sum to infinity. So for the sum to infinity here, let's just do that underneath then. What we get here is a all over 1 minus r, right? So a here is 3. That's all over 1 minus r. So 1 minus 2x. And we know then that the sum to infinity here is equal to 4, right? So we set this equal to 4. And all we need to do here then is just solve for x. So this should hopefully be nice and straightforward, given that we are studying A-level maths, right? This is basically a GCSE maths problem at this point. So just times both sides by 1 minus 2x. So I get 3 is equal to 4 lots of 1 minus 2x here. So expand this single bracket here with a term on the outside. I get 3 is equal to 4 minus 8x here. So I'm going to add 8x to both sides here and subtract 3 from both sides. I am kind of running out of room here, so let's just see if we can just about make it on. So 8x is equal to 1. 4 minus 3 is 1, right? And then finally, we just want x here. X is equal to 1 over 8. Gosh, perfect. Good stuff. There we go. So like you can see, part A here, I would say, is the most challenging part of this question, especially if you haven't seen a question like this before. Part B is pretty straightforward. You just need to be aware of this condition here for convergence. And then for part C, again, pretty straightforward, right? Just using the formula then for the sum to infinity and then just solving a straightforward equation, okay? But there we have it then. So that gives the solution here to the third tricky A-level maths exam question. As always, thank you for watching.